Imagine a planet being devoured from the inside out by a parasite of its own making, a black hole born from the very fabric of the cosmos. This isn't science fiction. It's a startling new possibility emerging from the frontiers of theoretical physics. New research suggests that planets bathed in dense clouds of dark matter could be ticking time bombs, with the potential to collapse into black holes in a cosmic catastrophe. But here's where it gets controversial. Some of these planets might not only survive but thrive with a black hole at their core, fundamentally challenging our understanding of what a planet can be. According to our best cosmological models, every galaxy, including our own Milky Way, is enveloped within an immense, invisible sphere known as a dark matter halo. The concentration of this mysterious substance is believed to be most intense at the very heart of the galaxy. While dark matter famously ignores normal matter, interacting only through the force of gravity, some leading theories, like the weakly interacting massive particle WIMP model, propose that its particles might occasionally bounce off or scatter from atomic nuclei. This subtle possibility has led two researchers from the University of California, Riverside, PhD student Mehrdad Forooten-Mehr and Tara Featherolf, to put forward a truly extraordinary hypothesis. They propose that dark matter particles could ping-pong off molecules within a planet, lose energy in the process, and become permanently trapped inside the planet's gravitational well. Over time, this captured dark matter could accumulate to such an incredible density that it triggers a gravitational collapse, spontaneously forming a microscopic black hole right in the planet's center. And this is the part most people miss. Their calculations, published in the prestigious journal Physical Review D, suggest this nightmarish transformation could happen with shocking speed, in some cases in under a year. Now, here's a point that is sure to spark debate. Not all planets would meet a fiery end. In a fascinating twist, Mehr explains that a planet's fate hinges on a delicate balancing act. If the nascent black hole is too massive, it will act as a parasitic engine of destruction, rapidly consuming the planet from the inside. However, if it starts out incredibly small, a quantum phenomenon known as Hawking radiation could cause it to evaporate into nothingness before it can do any real damage. And this is the part most people miss. There's even a theoretical Goldilocks mass, where the black hole neither grows nor shrinks. A planet could, in theory, harbor a stable, tiny black hole in its core for eons. Could such an object even be considered a planet anymore? We'd love to hear your thoughts in the comments. The likelihood of this entire scenario depends heavily on the still unknown properties of dark matter. A key factor is the mass of the individual dark matter particles. Lighter particles and more massive planets significantly increase the chances of capture and black hole formation. But there's a major catch that often divides physicists: the ability of dark matter to annihilate. If dark matter particles destroy each other upon contact, a feature of many popular models, they would release energy instead of building up to critical mass. If they don't annihilate effectively, then the path to forming a black hole is wide open. This idea of planets capturing dark matter isn't entirely new. Back in 2011, scientists Dan Hooper and Jason Steffen proposed that trapped dark matter annihilating inside a planet could act as an internal furnace. This could, for example, heat a world far from its star, enough to support liquid water and potentially life. Mehr and Featherolf's new work takes this concept to its most extreme and terrifying conclusion. Hooper himself has commented that the new hypothesis is worth looking into more carefully, but he also issues a crucial caveat. This dramatic outcome is only possible within a very narrow and specific subset of dark matter models. Do you think this makes the theory more or less plausible? If such planets do exist, how could we ever find them? One potential signature is heat. A planet with a small, stable black hole inside would be warmed by its Hawking radiation, potentially making it detectably hotter than astronomers would predict. However, the prime candidates for this phenomenon are planets orbiting near the chaotic center of our galaxy, some 26,000 light-years away. Even with powerful instruments like the James Webb Space Telescope, JWST, identifying a temperature anomaly would be incredibly difficult. And as Mayer cautions, a hot planet would have many ordinary explanations. Dark matter would only become a candidate after all other possibilities were ruled out. Another huge challenge is that gravity alone offers no clues. The Jupiter-sized planet and a black hole that has recently consumed a Jupiter-sized planet would have identical gravitational pulls. This means common planet hunting techniques that rely on gravity's effects, like measuring a star's wobble, radial velocity, or observing light bend around an object, microlensing, would be completely fooled. They could not tell the difference between a gas giant and a black hole in disguise. Before you look at Jupiter with newfound suspicion, rest assured, our solar system is almost certainly safe. Mayer clarifies that the density of dark matter is tied to distance from the galactic center. Out here in the galactic suburbs where we reside, the dark matter is far too sparse for our planets to capture any significant amount. The danger zone is exclusively in the downtown core of the galaxy. So for now, Earth and its neighbors are not at risk of turning into black holes.